Hey guys, today I want to continue a little bit with our talk about the environment. And in the last video I showed how to connect some LFOs to the IAC driver and then import them back into Logic. We're not going to do that right now, but I will point you towards that video with a link so you can watch that first, because that is sort of the step where I'm going from today. So if we're in the MIDI environment, normally you're gonna have a clicks and ports layer somewhere here, and I changed that clicks and ports layer and call it Jorgelet setup, just so I can customize this layer and import it into other projects. Now I have a whole bunch of stuff happening here, and you might wonder what that all is, because basically in most cases you're only gonna need one cable from your sequencer, from your physical input, which is this thing on the left side, and which are all the physical inputs, to your sequencer input, which goes to your main window, your tracks where you work. Alright, so I have all that stuff in between here. And what is that? Well, the things that are happening the most is transforming of signals. And I've renamed these objects, but actually they are transformer objects. And what the transformer does, it looks like this. And what it does is it takes one signal and it can change it into another signal. And you can use this for a whole wide variety of stuff. You can, for example, make your own MIDI velocity mappings. So let's say your keyboard is always way too responsive, right? So if you press the key not that hard, it might already give the loudest velocity. What you can do is you can make a transformer object for that. You can make a velocity map and map the input to the output. So in that case, you would probably use a map and make sort of an exponential curve, sort of like this, but then prettier, so that if your velocity is somewhere halfway, it will still give quite a soft curve, something like this. So this is then gonna be your own custom velocity curve. But there's a lot more we can do with that. So if we just follow this cable, I've sent the LFOs to the IAC driver, they get back into Logic, and the first step is they go here, and this is just a switch. So if I play Logic right now, nothing will be happening because that switch is set to this cable, which is empty right now, it's not connected. If I click it, it will switch to the other one, and now we can actually get input. So that's just an easy way for me to switch everything off if I don't want to use it. Now if I play Logic, we can see all these monitors filling up with data. So the first thing it hits is already a transformer, and that transformer is gonna say that all the MIDI channels are going to be 12. So whatever MIDI channel it receives, it's going to fix them to MIDI channel 12. So I know that it's sort of a safe way to make sure that you're always on MIDI channel 12. Well, then it gets to a monitor again to see if that actually worked, and it did work. And then after that monitor, I split it to several other transformers. So I'm just going to take one of these and explain what it does. As you can see, we have a monitor before this transformer and a monitor before the other one. And these are all copies of each other, so I'm going to remove these just to make sure that it's clear. This can be removed as well. So right now the input and the output look the same, but we can start to transform it. And the first box we need to deal with is the status. Right now the status is set to all, so that means that it's gonna listen to all input signals. But you can also let it listen to something that is equal to a note, for example, and then it will only, this transform window will only operate on notes and not on channel pressure, poly pressure, program changes, pitch bend, stuff like that. But if you set it to all, which is often the method I choose, it's gonna operate all notes, right? Then we can say true or fix. If we select true, it goes to the next box. If we say fix, we're gonna fix all messages to a new message. So we can fix all messages to a control message, for example. That means now if a note comes in, it listens to that note, it let it's true, and then it fixes it to a control message. So after that, it's not a note anymore. All right. So, but we're gonna let it true for now because we want the status to be the same. Then we can do the same with the channel. We can make it equal to. We can listen to only one channel, and then we can make it equal to something else. So now we say if the channel is 10, then do this. So it's a very, if you do coding, these are just these Boolean operations. If this, then that. If that is true, then do this. That's basically how it works. So if channel is 10, then fix, for example, channel 3. So now it converts channel 10 into 3. But because we're getting channel 12, it will not do anything. But if I say if channel is 12 and then fix it to 3, you can see in the first monitor the channel, which is the first number, is 12, and in the second monitor it's 3. So it has now converted the MIDI channel. Then there's another thing, another number right here. Maybe I should first explain this whole box. So the first icon there, that's gonna mean what sort of message it is. And the image we see right now, I don't even know what it looks like, but that's a MIDI CC message. That means control. And the second number is the channel. So we were on MIDI channel 12, so it's gonna be 12. And then we have the CC number, which is actually the identifier of the LFO or of the control. And if we go to our LFOs and I open that LFO, we can see that it's set to 103. And that's the CC number that the environment sees as well. So that's this second number. If I change this to 104, it changes to 104 here as well. And then the last number there, that's going to be the data. So that's going to be the actual position of the knob or of the LFO. If I make it quicker, it will go quicker. If I make it slower, it will go slower. So in the monitor, we can pretty much see whatever we want to see. So right now I fixed the channel to 3. That's the only thing I changed. But there are other things I can change here as well. For example, I can change that CC number, the 104. That's the number that the LFO is sending. And we can set it to, if the CC message is 104, then we can fix that to be CC message 6, for example. And now you can see that the 104 is the input, and also gives a 6 there, which is a bit weird, but the output is very clean. We get channel 3 and CC message 6. Now the last box is for the other data byte, and this is in most cases going to be the most difficult one to work with, but this maps the output to a different value. Like I showed with the velocity, we can say all data, and then we can map it to a new range. So if the range is too big, we can now change the range with the offset slider right here. But if the input was a MIDI controller with, for example, velocity or a pitch wheel, we didn't have that offset and output level. So then we can scale it here. We have a lot of different options. We can scale it, we can invert it, and we'll map it to new values. So you can set a max, for example, and then it only goes up to that point. So now if my LFO is on max output, it will still not give numbers higher than 64, because that's the half of the possible MIDI messages that we can have. So this is sort of a quick overview of this transform window and what you can do with it. There's way more interesting stuff that you can do, especially when we learn about fader messages, which is probably going to be the next video. So thanks for now. Experiment a little bit with this. It might be difficult in the beginning. It took me a while to sort of figure out how it works. But once you know this, there's actually a lot of fun stuff you can do in terms of experimentation and mapping MIDI controllers and MIDI signals. All right, see you in the next video.